Hello and welcome to all students. In this lecture, we learn about permutation with repetition. So, in the previous lecture, we study about the permutation. Now, permutation without repetition. Now, in this lecture, we study about the permutation with repetition. So, we have suppose we have n objects. Suppose we have n objects, and if n objects are to be arranged among themselves, okay, out of which p are identical of type 1. So out of these n objects, suppose p objects are identical of type 1, q objects out of n, q number of objects are identical of type 2nd. Out of n, r objects, they are identical of type 3rd, and so on. In this case, the total number of permutations or the total number of arrangements, total number of permutations total number of permutations are given by the formula n factorial divided by p factorial into q factorial into r factorial into dot dot dot. So this is formula. This is the formula which gives the total number of permutations of n objects if there are p objects are of identical type 1, q objects are of identical type of 2nd, and r objects are identical type of 3rd. So this is the permutation with repetition of objects. Okay, so let us take one example now. Let us take one example. Example 1. Find the number of distinct permutations. We write question: find the number of distinct permutations find the number of distinct permutations of the later distinct permutations of the letters of word word is given to be a surrounding. Yes, U double R O U N D I N G S, surroundings. Okay, so let us write the answer of this question. So in this question, what we have to do is we have to write the distinct permutations. Okay, so distinct permutations of the letters of the word surrounding. Okay, so this word surrounding contains total number of letters in a given word. So total number of letters in given word n equal to, so how many letters are there? Count 1 2 3 4 5 6 7 8 9 10 11 12. So there are 12 letters, and out of these 12 letters, so the letter yes, it is repeated how many times? 1 2. Okay, so only 2 times. Now the letter R, it is repeated how many times? R, it is repeated 2 times. Now the letter U, it is repeated how many times? 1 2. It is also repeated 2 times. Then the letter N, so letter N, it is also repeated how many times? 2 times. Okay, now see here, there is no any other letters which is repeated. Okay, okay. Now once we have that much information, you can write the total number of, now we can write the total number of permutations. Okay, therefore total number of permutations is equal to n factorial, means 12 factorial, divided by 2 factorial into 2 factorial into 2 factorial into 2 factorial. And if you if you find the answer of this, so it is homework for you, you solve this yourself now. Okay, okay, so this is about the permutation with repetition of objects. Now let us we start a next concept of combination. Concept of combination. Now we study the second important part of this unit. The name of this part is combination. Combination means a selection. Selection of object. Okay, it is called as a combination. We were discussed arrangements where the order of placement of the objects made a difference. We will now learn selection, in which the order of occurrence of objects does not matter. The main aspect of selection would be to know whether a particular object is selected or not. Here, too, like permutations, we are not interested in individual selection, but would like to know the total number of all possible selections. We give below the formal definition of combination. So let us write the definition of combination. So we write here definition. Okay, so suppose there are n objects. Right here, suppose there are n objects. Suppose there are n objects, a combination of r objects out of n objects. So here a combination of r objects out of n objects, a combination of r objects out of n objects. Here r is greater equal 0 and less equal n is to choose r things out of n things, is to choose r things in selection. Okay, is choose r things out of n things, when the order of choosing the object is immaterial. When the order of choosing object is immaterial. Choosing object is immaterial. Okay, is immaterial, full stop. The total number of such combinations is denoted by the total number of such combinations is denoted by the notation NCR. So this is the notation for combination of R objects out of N objects and it is defined as okay, defined as. So let us use red color to write the formula because it is very important. Okay, the formula for NCR. So NCR, it is equal to n factorial divided by n minus r factorial into r factorial. So this is formula to write the this is formula for selection or combination of r objects out of n objects. Okay, so n factorial divided by n minus r factorial into r factorial. So this is the formula. So now let us write some examples. Okay, So let us write the example 1. So what is value of 5C2? So 5C2 means selection of 2 objects out of 5 objects. So total number of ways. So this use the total number of ways to select 2 objects out of 5 objects. Okay. So and by formula it is 5 factorial divided by it is 5 minus 2 factorial into 2 factorial, it is equal to 5 factorial divided by it is 3 factorial into 2 factorial, but 5 factorial is okay. So it is, we can write 5 into 4 into 3 factorial divided by okay, and let us divided by okay, divided by it is 3 factorial into 2 factorial, so it is equal to 3 factorial, 3 factorial get cancelled. In the numerator it is 20 divided by 2 factorial is 2 and it is 10. So value of 5C2 is 10. Okay, so now similarly can we find the value of 7C5? Similarly we can find the value of 7, example number 2, 7C5. Okay, so by formula the value of 7C5 is equal to 7 factorial divided by 7 minus 5 factorial into 5 factorial, and it is equal to, so 7 factorial means 7 into 6 into 5 factorial, and whole divided by it is 2 factorial into this is 5 factorial. So 5 factorial and this 5 factorial get cancelled, and it is 7 into 6 is 42 divided by 2, and it is equal to 21, and it is equal to 21. So 7C5, okay, 7C5 has value 21. Okay, so in this way we have some problems now. Now let us we stop here and we end our lecture here. Okay, and thank you for paying attention. Okay.